So we'll be talking about a few more concepts of kinematics. Now, one very important concept of kinematics is about relative velocity. For that, you need to understand something known as frame of reference. Now, a frame of reference is a frame whose reference you take while analyzing the motion of any object. Now, the question is, what do I mean by that? First, what is a frame? A frame is basically a set of x or y coordinates which are used to analyze the velocity and the position of the particles in that particular frame. So, whenever we say that there is an object or a particle having certain motion, that motion is always relative to something. For example, you might be sitting in a car or in a train, and suppose if you have a ball in your hand, suppose if you toss that ball slightly, so suppose if that ball goes slightly up and then it falls back to your hand, in that case, if you're sitting inside the car, what you will see, the motion of the ball is that you will see that the ball will go up straight by some amount and then it will fall back, come back to your hand. Right? But to a person who's standing on the road, how will the motion of the ball look like? Like this. So, why is there this difference that inside the car the motion of the ball is in this way and inside from the road the motion of the ball looks like this? Because the road is a different frame of reference and your car is a different frame of reference. For example, this pen. If I keep this pen on this copy, I can say that the pen is stationary and it is not moving. But is that actually true? It is not true. Why? Because this pen at the end of the day is an object which is on this earth and earth is moving. So pen is also moving, right? So pen is moving in the frame of reference attached to this universe. So basically, whenever you are analyzing or whenever you say that there is a particle with a certain motion, that motion is always relative to certain frame of reference. So that is as the name suggests, frame of reference. So it's a frame which is used for reference. And you say that there is this frame of reference which is fixed to the ground, there is a frame of reference which is attached to the car, or you can say that the frame of reference of the car, and so on and so forth. Now there is another concept which is in fact a very closely related concept, that of a relative velocity. Suppose if there is a particle, say A, which moves with certain velocity, say 20 meters per second square, say per second, and there is this another particle which moves with a velocity 10 meters per second. Okay, and this particle are in the straight line. This is one line only. So this particle is A and this is B. What is the relative velocity of B with respect to A? We can denote that by this. This will be equal to VB minus VA. Since VB and VA are in the same direction, this will be 10 minus 20 minus 10. Now what does it mean? It basically means that the relative velocity of B with respect to A is minus 10. It means that in a frame of reference fixed to A, you can see that B is moving with a speed 10 meters per second, not in this direction but in this direction. This is why this minus sign is there. So if there is, say, any person who's sitting on A, that person will think that A is at rest, and for that person B will appear as if B is moving towards A with a speed of 10 meters per second. So this is what is relative velocity. and whenever the relative velocities or the two actual velocities are in the same direction, you just have to subtract to find out the relative velocity, right? You just have to do Vb minus Va, and it's just a normal subtraction. Why? Because these velocities are in the same direction. But if the velocity vectors are at an angle, this is Va, this is Vb. Suppose in that case, what is basically these are two particles A and B, A having a velocity Va, B having a velocity Vb. What is the velocity of B with respect to A? Again the same, Vb minus Va, but this time it will not be a simple subtraction, and the reason being it's a vector quantity, velocity is vector quantity, and these velocities are not in the same direction, they are at an angle. So that is why you have to do a vector subtraction. Now, what is the way of doing a vector subtraction? Suppose we have a velocity, say v. It will have a x component Vx and a y component Vy. So this angle is theta. Vx will be equal to v cos theta, and Vy will be equal to v sin theta. So this vector difference will be equal to, how can you find out the vector difference? You take the x component of B, y component of B, you take the x component of A, y component of A, subtract the y component of B with the y component of A, subtract the x component of B with the x component of A, and the resultant will be equal to this. Vr is the resultant velocity, this is Vrx is the resultant velocity x component, resultant velocity y component. This is Vbx minus Vax, this is Vby minus Vay. I'll just write it down. Vrx will be equal to Vbx minus Vax. Vry will be equal to Vby minus Vay. Also, tan theta will be equal to Vry divided by Vrx. Right? So this is how it will work. So this is the concept of resultant velocity. This is how you find out the resultant velocity vector, because there are many situations where you have to find out the resultant velocity vector. One such situation is that of a river. Here there is a river. This is water, okay? Suppose if this river flows in this direction with a certain velocity, say Vr. Suppose if there is a swimmer which has a velocity some Vs with respect to the river. Now, what is the resultant velocity? So this is just one example of a situation where you have two velocities and you need to find out the resultant velocity. Now, Vs is the velocity of the swimmer with respect to the river. Vr is the velocity of the river with respect to the ground. This is the river and this is the bank of the river. So this is, I have denoted it using VR, but this is actually VRG, velocity of the river with respect to the ground, and this is VSR, velocity of the swimmer with respect to the water. So what it basically means is that, suppose if, say, this angle is 90 degrees. So what will be the resultant velocity? Vs plus Vr. Resultant velocity of the swimmer with respect to the ground. Because there are two components of this velocity of the swimmer. One component where the swimmer is swimming with respect to the water, and that velocity is Vs. It is at an angle of 90 degree with the flow of the water, with respect to water. So if you are flowing on the water, if you are going along with the water, you will see that this swimmer is coming 90 degree to you. So with respect to the water, the velocity of the swimmer is Vs at an angle of 90 degree. So suppose if there is a boat, or say something known as a raft. A raft is basically any piece of wooden plank which is there on a river, which basically moves as fast as the river water. So velocity of a raft is equal to the velocity of the river. So if you are on a raft, you can look up raft in Google if you are not able to understand what a raft means. Say there is this raft. If you, by chance, if you are able to stand up on that raft, the raft is moving as fast as Vr, and from that raft you will see that the swimmer is moving 90 degree. So from the frame of reference attached to the raft, I will see that the swimmer is moving at 90 degrees. So the resultant velocity of the swimmer with respect to the ground will not be this 90 degree. It will be Vs plus Vr, because this swimmer will have two components of velocity. One will be Vs and the other will be Vr. So all that you have to do is you have to find out the vector resultant of these two velocity vectors. One is the Vs, velocity of the swimmer, the other is Vr. So this is one thing. This logic is applicable to the case of a boat as well. Even if you have a boat, the same logic can be applied. Also, there is something known as upstream velocity and downstream velocity. So there is a river and there is a boat. This is water, and there is this boat which travels in this direction. The velocity of the river also is in this direction. So the velocity of the river is Vr and the velocity of the boat is Vb. In this case, this direction of the direction in which the river is flowing is known as downstream direction. In that direction, the net velocity of the boat with respect to ground will be Vb plus Vr. This is the downstream direction, and opposite of downstream is the upstream direction. Say the boat is going in this direction, the river is flowing in this direction. In that case, what is the velocity of the boat with respect to the ground? The same basically. It's just that in this case one vector will be a negative vector because the direction of Vr or Vb is opposite. Right? So in this case, downstream velocity of the boat with respect to the ground will be equal to Vb minus Vr. Okay, so you have to subtract it in case of a downstream, in case of upstream motion. So in case of an upstream motion, the velocity of the boat, from that you have to subtract the velocity of the river. In case of an upstream motion, you have to add the velocity of the boat and the velocity of the river. Sorry if I got that wrong. In case of downstream motion, resultant velocity will be equal to velocity of the boat plus velocity of the river. Upstream motion, resultant velocity will be equal to velocity of the boat minus the velocity of the river. Why? Because in this case the boat is going in the opposite direction. Now this is one example of a situation where you are required to find out the resultant velocity vector. You can have other situations as well. For example, there is a situation where a cyclist or a car driver or a bike driver is traveling on the road and it's raining. Okay, so we can assume, we assume that the rain falls with the velocity v0 straight down. This is the ground surface. Rain falls with the velocity v rain perpendicular to the ground. Car travels with the velocity, or bike travels with the velocity v car, something like this. This velocity is with respect to the ground. Vr also is with respect to the ground, right? Vc is parallel to the ground, and Vr is perpendicular to the ground. Now suppose if you want to find out what is the relative velocity of the rain with respect to the car. Again, Vr minus Vc. Right? Vr plus minus Vc. What is minus Vc? Just opposite of this vector. So this vector is this, like pointing towards this direction. Minus Vc will be Vr Vc. Okay. So Vr plus minus Vc, Vr minus Vc, resultant will be something like this. So if you're in the car or a bike, you will feel that the rain is hitting you at an angle. This angle will be some theta. Okay. And tan theta will be how much? Vr by Vc. What is the impact if you increase this velocity? Say you're traveling on a bike and you speed up the bike. How will the rain now fall once you have increased the speed of your bike? What will happen? This velocity vector was like this. Rain is still falling downwards. Velocity vector is like this. Why? Because you've increased the velocity of your bike. Velocity of the rain with respect to car or bike is equal to Vr minus Vc. Minus Vc. This is plus Vc. This is minus Vc. This plus this is equal to this. So this is greater than this. This was the initial velocity. You have increased the velocity, so this is greater. So since this is greater, this angle comes down. Since this angle comes down, now you will see that the rain is, earlier it was falling like this. Like this. Now it will fall like this as you increase the velocity. On the other hand, if you decrease the velocity, you can imagine Vr will be the same, Vc will come down. So now the angle will be like this. This angle is always, say, gamma. gamma will be more than alpha, because this is constant, this has come down, so this by this will be tan theta, and since this has come down, so tan theta has increased, so theta has increased, so in other words gamma is more than alpha. In other words, when you decrease the velocity, the rain starts to fall like this. Earlier it was falling like this, now the angle with the horizontal will increase. Earlier it was this, now it will be this, like this. And like this, if you keep on further slowing down the speed, this angle will continue to increase till at a point when you reach a speed of 0. At that point VR will be, or relative speed will be VR. You will see that the rain is falling vertically. So this is the rain bike problem. It's example of situations where you are required to find out relative velocity, do vector addition or vector subtraction. So one thing that I would like to tell you is that this example, when I said that particle A and B are moving in the same direction, this is 20 meters per second, this is 10 meters per second. So these are all speeds with respect to the ground. So VBA is equal to VB minus VA. So this VB is with respect to ground. This A is also with respect to ground. Right? So this is one thing that I wanted to point out. So the question is like this. Let's look at the first question. A motorboat going downstream a motorboat going downstream overcame a raft at a point A. T equal to or tau equal to 60 minutes later, it turned back, and after some time it passes the raft at L equal to 6 kilometers from A. Find the flow velocity. Flow velocity means the velocity with which the river is flowing. So this is the river. I will not draw the river because it's not strictly required. There is a point A. As I already said, that a raft is something that moves along with the river and has a velocity equal to the velocity of the river. So there is a boat which overcomes a raft at a certain point A in the river. Then it goes ahead for 60 minutes. It reaches a point and then it turns back. And then after some time it meets the raft at say a certain distance, say that is D from the original point A. Now during this time, a raft also moves because the river is continuously running and the raft moves along with the river. The velocity of the raft is equal to the velocity of the river. Find the flow velocity or the velocity of the river. Suppose the velocity of the river is say R. velocity of the boat is say VB. So downstream velocity will be VR plus VB, and upstream VB minus VR. Time that the raft needs to reach from a point this to this is equal to the time that the boat travels this distance plus this distance. This distance is just traveled with VR plus VB. This distance it travels with VB minus VR. So if you equate the times, what will you get? D by VR is equal to total distance. How much is the total distance that the boat travels upstream? It says here, motorboat going downstream, how much distance the boat travels? The motorboat going downstream overcame a raft at a point A. 60 minutes later, it turns back. So for 60 minutes, it goes downstream. So suppose if T is that time interval where it goes downstream. So what is this total distance? T into VR plus VB. Time for the boat to travel from this point till this will be equal to T. Plus total distance, time will be equal to T actually. I'm making a mistake here. Time for the boat to travel from this point to this point will be equal to T. Okay, let's write it again. D by VR is equal to T plus time for the boat to travel this distance plus this distance. Time to travel this distance we know is T. Right? 60 minutes later. This T is equal to 60 minutes. 60 minutes later it turns back. So for 60 minutes it travels downstream. So time for this boat to travel from here to here till it turns back is T, and after that it travels upstream for this distance. So how much time it travels this distance upstream? Total this distance by velocity. What is time? Time is distance by velocity. So the question is, how much is this distance? This distance is equal to this minus this. How much is this? Total distance traveled downstream, which will be equal to T into VR plus VB. Velocity into time is distance, so total distance traveled downstream is equal to T into VR plus VB. This is the total distance traveled downstream minus D. This is this distance. Now I will divide this distance by the velocity at which the boat is traveling this distance. That velocity is the upstream velocity, VB minus VR. So if you solve this equation, you will get the answer. It's very simple actually. This will be equal to D by VR is equal to L by 2 as per the notation which is used in this question. So the only thing that you've done here is you've said that the time for the river, for the boat or for the raft to move from this point to this point will be equal to the time taken by the boat to move from this point to this point plus time taken by the boat to move from this point to this point. That is the only thing that is required here. So this is the solution.